my turn. So when we use Pythagoras in 3D, we need to first take stock of what we've been given, what we want to find out, and how we're going to go between the two. So I want to find this diagonal here. This diagonal is existing almost from the top of one edge of the box to the bottom corner of the other. So it's existing exactly throughout kind of this box, this cuboid shape. So what I'm going to need to do first of all is I'm going to need to find the length of its base. That way it'll give me a second right angle triangle to work with. So let's consider the base first. I have a rectangular base with the dimensions of 6.3 centimeters and 8.7 centimeters. I want the diagonal here. You'll notice this forms two right angle triangles, which means I can use Pythagoras. So I'm going to label this length n that I'm looking for just to help me out a little bit, make my workings a little bit neater. So now, using Pythagoras, I know I'm going to get n squared is equal to the other two sides because n is existing as the hypotenuse. Opposites are right angle, but also the longest length. So n squared is equal to 6.3 squared add 8.7 squared. Typing this into a calculator, that's going to give me 115.38. You could put units here, obviously it would just be centimeters, but this isn't a value, this doesn't tell us anything at the moment. So now to find n, I have to square root that value, so I need to square root 115.38, and that is going to give me 10.74. It does carry on. It's quite a long decimal, so I've rounded it to two decimal places here. You don't have to round it to two decimal places. If you have the answer function on the calculator that you're using, like I'm going to continue to use that long value and only round at the very end. If that isn't an option for you, possibly you're using a phone or a calculator that doesn't have that function, use the value rounded to two decimal places. You could use 3 or 4 if you prefer. But if you're doing that, make sure you state that you've rounded this value. So if you are going to use that, you're going to state that. Otherwise, you could just say that. And then you would carry on. So like I'm going to do now, I found that length. I now need to consider what I now have. I now have this triangle. So I have a base of 10.74 and the rest. And I have a height here of 5.2. I'm just going to go about using Pythagoras again because I want to find x, which is still existing as our hypotenuse. If it wasn't our hypotenuse, once you put it into the Pythagoras theorem, you're just going to rearrange slightly to find the value you're looking for. So I'm going to get x squared is equal to 5.2 squared add 10.74 and the rest all squared. That is going to give me a value of 142.42 centimeters, but again that doesn't actually tell me anything just yet. So when I square root it to find x, I'm going to get a value of 11.93. Now it's important to have that unit, and I've also rounded that to two decimal places, so I'm just going to state that on the end. There's a lot of steps here. You're going to need to work out that distance across the base, then work out your actual triangle with your unknown. So be really careful, use these steps carefully and break it down. Draw diagrams, break it down into separate diagrams if you need. This might take a lot of workings, but they're really, really good questions and easy once you get into the rhythm. So pause the video here and have a go at the your turn question. Your turn. So for this question, similarly to as I did in the my turn, I'm going to start with the base. This time is slightly different. I've got 5.2 and 6.7. Going to plug that straight in, looking for that n value on my base. So I'm going to get n squared is 6.7 squared add 5.2. 2 squared. That's giving me a value of 71.93. So when I square root it to find n, I'm going to get a value of 8.48. And the rest, if that could be rounded to 2 decimal places, or like I said before, you can carry on with the long decimal if that is an option on your calculator. You're then going to consider what that means. That means I've now found this value here. So what I now have is a second right angle triangle, which looks something like this, with a base of 8.48 and a height of 3.3. Once again, I'm looking for that hypotenuse, that longest side opposite my right angle. So I'm going to be using Pythagoras again. In the same way, not too much rearranging needed. So I'm going to get x squared is equal to 3.3 squared. Add 8.48 squared. If you are carrying on, obviously that will be the slightly longer decimal. That should give you then a value for x squared of 82.82. which when square rooted is going to give us a value of 9.10 to 2 decimal places, or to the nearest whole number, 9. Use these examples to have a go at the next set of questions.